Hey everyone, how's it going? My name is Sean Hodgins and welcome back to my channel. So I have a project coming up that's going to require the use of some really tiny and lightweight actuators, and you can't really buy them off the shelf. So I've actually discovered a way to make them, and you can 3D print them, and making them is actually pretty simple and they work really well. So let's build one, then I'll talk about how they work. Let's get to it. Okay, so now that you've 3D printed the main body parts, some other parts you're going to need is a magnet. I'll leave a link below for this one if you want to use my parts, but any magnet will work. I'm using a resistor, but just for the lead wire. It's got a thick lead wire on it, and it's going to hold this centerpiece in. I'm just using it basically as a metal rod, so whatever your design calls for. And you need some thin gauge wire. Now you can just buy this. You can also scavenge this from motors. This one's actually out of an old electric clock, those really cheap clocks. This is the coil in that, and it's got some really fine wire in it. And this is probably what I'll be using for the smaller version. But right now I'm just building a larger scale to test out the concept, and then for the future project it's going to be much smaller than this. You're also going to need some electrical tape. Just a really small amount, just to hold the leads in. So let's put this together. That was easy. Okay, let me show you how I did this. Okay, so first what I did was I cut some of the resistor leads so that they were really small pieces that would fit in the holes of the body straight through and into the actuator arm. Once I got those in both sides of the actuator arm holding it in place, I took some electrical tape, covered over the holes so the rods wouldn't come out, and then the actuator arm is stuck in place. After that I took some of the thin gauge wire and I hooked it up to something solid and far away so that I could get a nice long strand of it, and then I slowly wrapped it around the core. It doesn't really matter what direction right now because you can change that later on, just reversing the polarity of the wires that are connected to it. Once I had that fully wrapped up, I just secured the wires so that they wouldn't come undone, and I soldered them to a couple of headers. Now in order to drive this, you need to run a current through the wires, and when you run a current through the wires, it's going to make the actuator move in different directions. I'm going to hook up a little microcontroller, an Adafruit trinket, to a motor driver so that I can provide the adequate current for this, so I can test it out and program a small program to see what it's capable of doing. Okay, the setup that I've got here is an Adafruit trinket. These are really handy, keep them around for small little projects like this. Then I've got the DRV8835 motor driver. This is a little breakout from Polulu. I use it for testing. It's pretty much the motor driver I use for all of my robotic things. And then it's directly connected to this actuator, and I've got the actuator hooked up to my power supply just so I can provide enough current for it. What the program is set to do is just change the polarity of the DC power that's going to this coil. So I'm going to turn on the power supply. We should see the actuator move. And it works. And if we change program, just say every half a second, you see we can control the actuator based on what we program, which is obviously the idea. Okay, so what is going on here? Well, if we can see that the orientation of this coil to the magnet has its north and south going this way. I don't know exactly which way, but vertical, and we've got the coil going this way. if you put a current through this coil, it's going to generate a magnetic field, and that's going to cause a reaction in the magnet depending on which way the current is flowing. So if you have the current flowing in one direction, it's going to make north and south go this way, either north going that way, south going this way, or the opposite. And with the magnet sitting this way, it's going to oppose that direction. The magnet wants to be sitting in the same orientation of the coil, but right now it's not. So when you put that current in, it's going to force the magnet to try to turn in one direction and then sit that way. If you imagine that this actuator wasn't here, the magnet would be able to go all the way and turn, and it would sit happily inside the middle of this coil. And when you change the current to the other direction, it's going to try to oppose it the opposite direction. And it works surprisingly well and has quite a bit of force, though it does require more current than desired right now. But I think with a better coil design and not loosely wrapped like I've done it, you can make something that is very usable in small robotics. And this is entirely scalable to incredibly small sizes. I've seen some RC projects where you're basically making an RC paper airplane. That's how small they make these actuators. So if you want to make one of these actuators, I will obviously provide all the resources, all the files for you to download, and what parts you'll need to build one. However, I do encourage you to try and design your own. It's quite a simple design in the first place. So if you download something like Fusion 360, this would be a good starting place for something that you could build yourself and then actually have your own little robotics application. Now if you like this video, please give it a thumbs up. Hit that subscribe button if you enjoyed all of my videos, and we'll see you on the next project, which is going to be super cool. May not be the next video, but it'll be the next major project. Anyways, everyone, be good and have a good day.